It's 1966. The GTO is already a legend. Pontiac is selling V8 performance as fast as they can build it, and every other division at General Motors is doing the same thing. More cubic inches, more horsepower, bigger carburetors, louder exhausts. That was the entire conversation. Displacement was the answer to every question Detroit was asking. And then Pontiac's engineers did something nobody expected. They built a 6-cylinder engine with an overhead camshaft driven by a rubber belt, capable of spinning cleanly to 6,000 RPM, with a sprint performance variant that car and driver called the most exciting American Six ever built. It ran for 3 model years. Then, General Motors decided the tooling was too expensive. The Chevrolet Pushrod 6 replaced it, a design with roots in the 1950s that cost almost nothing to produce because the tooling had been paid off across millions of units a decade earlier. This is the story of the 1966 Pontiac OHC Six. The engine that proved overhead cam technology worked in an American production car got replaced by something older and simpler, and then watched from the sideline as the rest of the world built exactly what Pontiac had already proven. To understand why the OHC Six mattered, you have to understand what American inline six engines were in 1966. They were workhorses, pushrod designs, largely unchanged in fundamental architecture for decades. They made power down low, ran out of breath at high RPM, and existed primarily to give entry-level buyers something cheaper than a V8. Nobody at Ford or Chrysler or General Motors was asking their 6 cylinders to be exciting. Pontiac's engineers asked a different question. What if the 6 was not a penalty? What if it was a performance statement? The engine they built displaced 230 cubic inches and used a single overhead camshaft. That camshaft was driven not by a gear train or a timing chain, but by a toothed rubber belt, a Gilmer-type industrial belt adapted for automotive use. No American production car engine had done this before. The same belt also drove the distributor and alternator, creating a fully integrated accessory drive from a single component. It was elegant in exactly the way that Detroit's conventional wisdom said it did not need to be. The result was an engine that behaved fundamentally differently from everything else in its class. Where a pushrod 6 ran out of composure above 4,500 revolutions per minute, the overhead cam 6 kept pulling cleanly to 6,000 revolutions per minute. The Sprint performance variant pushed that further. A 4-barrel Rochester carburetor, revised intake porting, and a tuned exhaust brought output to 215 horsepower at 5,200 revolutions per minute. Car and driver called it the most exciting American Six ever built. The European press, accustomed to sophisticated sixes from BMW and Alfa Romeo, took the Pontiac seriously. Every engineering decision was made in service of performance, rather than parts bin commonality. That last sentence is where the story starts to turn. The OHC Six did not exist in a vacuum. It existed because John DeLorean wanted it to. DeLorean was Pontiac's general manager when the engine went into development, and he understood something that GM's corporate structure preferred to ignore. Pontiac's value to the corporation was its engineering identity. The GTO had proven that. The OHC Six was supposed to prove it again, in a different direction. Malcolm McKellar, Pontiac's chief engineer, led the development team. The challenge was not simply designing an overhead cam layout. European manufacturers had been doing that for decades. The challenge was convincing General Motors that the unique tooling investment was justified for a 6-cylinder engine in a market obsessed with V8 engines. DeLorean made that case internally. The engine went into production for 1966. For 3 model years, the OHC Six was exactly what DeLorean said it would be. The Sprint variant gave Pontiac a credible performance story that did not require cubic inches. And underneath the hood, the rubber timing belt was demonstrating something that would matter enormously to the global industry within a decade. Then DeLorean moved to Chevrolet in 1969. The same year, the OHC Six was discontinued. That timing is not coincidental. DeLorean's presence at Pontiac had been the engine's internal political protection. When he left, the engine faced GM's corporate cost rationalization logic without an advocate. The logic was straightforward and completely indifferent to engineering merit. The OHC Six required tooling unique to Pontiac, costs that could not be amortized across divisions. The Chevrolet 250 inline six was already in production, already paid for, already running in millions of cars. It made less power. It revved less cleanly. It was decades older in fundamental design. It was cheaper. And at GM in 1969, that was the argument that won. What replaced the OHC Six was the Chevrolet 250 cubic inch inline six. It was a pushrod engine whose basic architecture traced back to the 1950s, optimized over years of production for one thing above all others: low manufacturing cost. The Chevrolet 250 made 155 horsepower in standard tune. The OHC Sprint had made 215. Every metric that car and driver and motor trend had used to praise the Pontiac, the rev character, the breathing efficiency, the high RPM smoothness, was gone. But here's where the story takes the turn that should have been Pontiac's to claim. Through the early 1970s, Japanese manufacturers began introducing overhead cam engines with rubber timing belts across their passenger car lineups. Honda, Toyota, Datsun. The toothed belt that Pontiac's engineers had validated in a production car environment in 1966 became the standard drive mechanism for overhead cam engines worldwide. By the early 1980s, it was difficult to find a new passenger car engine from a major manufacturer that did not use an overhead cam driven by a rubber belt. Pontiac had proven this concept first, in production, at scale, under real-world conditions. The General Motors corporate structure decided the proof cost too much, so another industry, working a decade later, built the future Pontiac had already mapped. There was no licensing arrangement, no recognition in the mainstream automotive narrative. The engineers who spent years solving the durability questions around belt-driven overhead cams got no credit as the technology became universal. The institution that abandoned it did. What would have happened if General Motors had committed to developing the OHC Six through the 1970s? The engine was already proven. The belt technology was already validated. The performance ceiling had not been reached. A properly resourced second and third generation could have given Pontiac a distinct powertrain identity in exactly the decade when Honda and Toyota were building their reputations on precisely that kind of engineering sophistication. Instead, Pontiac went to a pushrod 6 that was old before the OHC Six was born. Engineers were right about what the technology could do. Accountants were right about what it cost. Nobody was wrong. That's what makes it difficult to watch. The timing belt Pontiac pioneered became so standard that an entire generation of mechanics grew up treating belt changes as routine maintenance on Honda Accords, Toyota Camrys, Volkswagen Golfs. On every engine built to an architecture Pontiac had already validated, then discarded. The mainstream narrative calls the OHC Six a footnote. The engineering record calls it a proof of concept that the global industry confirmed within a decade, without ever returning the credit. They replaced it with a pushrod 6 designed before Eisenhower was president. The math was correct. The decision was still wrong. The engine didn't fail. The institution failed the engine. There's a difference, and it matters. If Pontiac had developed the OHC Six through the 1970s, would it have given the brand the engineering identity it needed to survive into the 21st century? Or would GM have rationalized Pontiac out of existence regardless? Drop that in the comments. Subscribe for more of Detroit's engineering history that the mainstream narrative decided wasn't worth telling.